Let's look at our question here. Solve the problem. That's the story problem with parabola or quadratic function. It's a quite interesting question in our daily life. We want to maximize this area of the rectangle. You have 112 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the site along the river, find the length and width of the plot that will maximize the area. We have 4 different choices right here. Which one is correct? Since the site along the river is not needed to be fenced, then we have if this side is the width, this side will be the same width. So if we assume this is x, this would be another x. They are equal. Then the width will be the total length, 112. Subtract this x, and the second x together is subtract 2x. And this will be our width. And then we know the length times the width, we will have the area. That's what we got here. Now, from here, we can then find out the dimension by using the quadratic function. We first distribute x to negative 2x, so we have a negative 2x squared. And x is distributed to 112, so we have 112x. Now, we need to make this one be a complete square. We pull negative 2 out, then inside is x squared minus 56x, and we use parentheses right here. How to make a complete square and why do we need that? You will see right away. Okay. To make a complete square, again, we always divide the coefficient of x into half, which is negative 28. And then we square this negative 28, and we have to subtract the square of negative 28 squared, because these two will cancel each other, make the equation be the original one. Originally, we do not have this red one number subtract another, and we only have the black words right there. The reason I'm adding negative 28 squared is because the first 3 terms together is going to be a complete square. You may FOIL this one out. X minus 28 times x minus 28. You can FOIL this one out. It's going to be back here. Okay? Because again, x minus 28 times x minus 28. You have x times x. For your method is x squared. The last term is negative 28 squared. The middle term, inner term and outer term added together is going to be this one. Okay, minus negative 28 squared is 784 positive. And then you have a minus here, you leave it here. And then we distribute negative 2 to the first quantity and the second quantity. And then we have a negative 2 times this quantity, x minus 28 squared, and negative 2 times negative, you got positive. 784 times 2, you have 1,568. When can we maximize this expression? It is quite clear. X minus 28 squared is always positive. You then times a negative number is always negative. So this first part is always negative. The maximum value is 0. Okay? The second value is positive. So if you want to maximize this AX, this value needs to be 0. If it's not 0, it's going to be negative. And then this value minus a negative number, it is always make this one smaller. So then we want the first part to be 0. So 1,568 minus 0 is going to be the maximum value of this area. So that's at the time when x is 28. X is 28 minus 28 is 0. Squared, you get 0 times negative 2, you get still 0. Then 1,568 will be the maximum value. So we choose x is 28. And that will be our width right here, 28. Here x is 28. Then how about the length? The length, you calculate that. If you have 2 times 28, then 112 minus 2 times 28. 2 times 28 is 56. So 112 minus 56 is still 56 feet. So we are done because we know the width is 28, the length is 56 feet. So that would be our third choice. Okay, third choice. Now, by the way, if you have the x is 28, that's width, and if you have a length is 56, 56 for the length times width, 28, you shall have 1,568 right here. You can use a calculator to try it. Okay. And on your calculator, 28 times 56 is 1,568. You know, this quadratic function is given in this way. If you want to use decimal, you can find out. And then that's the equation you input right here. And then you can see here, the graph looks like that, reversed. And then the highest point is x is 28 right here, and you have y value is the highest, 1,568. That's right here. Okay, that's the math. Actually, it's very useful. Okay, hope you get that and put into your application in future. Okay, all right. I'll stop right here and see you later.